Hello everyone, I am Anita and I'll be presenting the topic Analyze Digital Forensic Evidences through a Semantic-based Methodology and NLP Techniques. The topic listed here will be discussed in detail as we move further. As an introduction, the cybercrime are the crimes for which the IT or the telematic systems are the object of the offense, or it is the crimes for which the information or the telecommunication system are the tools of the criminal actions. The motivation for this are digital evidence can be considered any data that is allocated to a particular device or transmitted by IT and the telematic systems that may have some procedural relevance. The repeatability of the investigations. What do we mean by this is the possibility to completely rerun the analysis on the models absolutely identical to the original multiple times in order to improve our analysis. The best practice and the regulations are as follows: acquiring the test without altering or damaging the device originally, authentication of the find and the image acquired to guarantee the repeatability of the assessment, and analysis without modification of the original data, maximum partiality in the technical section. Methodology phases. Identification is the process of research, recognition, and the documentation of the potential evidences in the digital format. The collection phase consists in obtaining materially the data to be analyzed. Acquisition is the process of producing a copy of the digital evidence called a forensic copy, which is a complete copy of the media, including the unallocated space and the slack space. The analysis activity consists in recovering those data that may be useful for the purpose of forensic investigation, which are likely to be hidden voluntarily or not. Evaluation of the data acquired for the analysis purpose. And finally, the presentation of all the evidence found by the consultant and his conclusions in the detailed report that will be considered during the trial. The architecture of the analysis systems consists of the following modules as it is pictorially represented in this diagram, which includes the evidence collection, unstructured data collection, semantic representation, inferential and rule-based reasoning, visualization, and the query. Evidence collection loads the binary data from the acquired data. This module provides different tools to extract relevant artifacts from a forensic image. The unstructured data processing has two modules, the text processing module and the multimedia processing module. The text the text processing module includes the linguistic and the semantic analysis, and all the NLP techniques that we have studied so far is used in this particular section. All the POs tagging and the lemmatization, the stemming, everything. So the multimedia processing aims to classify multimedia objects associating concepts from the domain ontology. This module exploits the artificial intelligence techniques such as the machine learning, convolutional neural network, etc. Semantic representation module generates an OWL, which is the web ontology language representation of the knowledge extracted from the digital evidence in the previous step. For an example, in figure 4, is reported the graphical representation of the computer network ontology schema. This is very similar to the enterprise relationship diagram in the sequel, but that is for a structured relationship database, but this is for an unstructured language. The ontology population is made by creating an instance of each footprint item by acquired data and by linking them each other according to the formal object properties defined in the ontology schema as represented in the figure 5. Inferential and the rule-based reasoning. In this, we use the SWRL, which is called as the Semantic Web Language rules, which play a major role in the automated integration and the correlation parts of the methodology. The SWRL rule engine adopts SWRL rules in order to correlate different individuals or to establish relationships among the individuals belonging to different ontologies but representing similar concepts. Here, The listing one reports an example of the SWRL rule inferencing the orphan connections through a set of network traffic records. Visualization and the query. In this final module, which is responsible for accepting the SPARQL queries from the user and evaluating against a SPARQL query engine. An example of a query is shown in the listing 2 and the result is shown in figure 6. Evaluation phase, we use a collection of the logging files to test the evaluation steps which was acquired in the initial steps of the forensic data collection. Over here, the table 1 shows the number of events for each category of the considered data. For the log files, we have the different log data, which is the critical, the error, the warning, the information. And each number and the log files, this number gives the number of events that has occurred in the list of log files. The table 2 are the reported number of events for all the categories and the manual labels. In the last column is also reported the number of detected events through the presenter methodology. Here, the figure 7, we can observe that the prototype system detects a large fraction of the relevant documents within the considered dataset. In figure 8, it is clearly shown that for most representative categories of the events, those containing a great number of events, the detection rate is greater than 85%, while the reported rate of false positive is never greater than 3%. In here, the table 3 reports the number of extracted entries, the number of triples generated during the enhancement phase, and finally the number of significant correlations found. And here the table 4 gives the execution time for the different phases of the process. From table 4, we can derive that the analysis phase is the most time consuming step. As the future works, we can make further development of the framework in order to improve the performance of the analysis phase and the suitability of the extraction phase to a wider range of devices and sources. Moreover, we are investigating the exploitation of the machine learning and the multimedia analysis techniques, aiming to the production of more meaningful representation of the multimedia resources. For example, by annotating an image with the name of the location or the name of the subjects. As a conclusion, we can say that in this work, we presented an extensible methodology that exploits text processing techniques to represent relevant concepts of specific domain in a standard and formalized format, according to semantic web principles. We consider the computer forensics domain to face off this information extraction and retrieval challenges and to enhance the correlation of the collected evidences. This approach intrinsically brings the advantages of making relationships between the domain entities and of the reasoning and the inferential mechanism. Lastly, here are the list of references which can be of very helpful for you. Thank you so much for this opportunity.